I'm Jaewook, and today I will be presenting our work on how different image exploration modalities designed for blind or visually impaired individuals can encourage skepticism towards imperfect AI-generated image captions. This work was done in collaboration with Jaylin Herskovitz, Yi-Hao Peng, and Anhong. Traditionally, blind or visually impaired individuals rely on alternative text or alt text to understand the contents of an image. However, alt text is often missing, leaving many images inaccessible. Auto-generating alt text is a scalable alternative, but AI-generated captions can be incorrect or incomplete. Even if the auto-generated captions are inaccurate, without the means to verify correctness, blind or visually impaired individuals place a high degree of trust in them. Image exploration systems attempt to resolve this problem by providing additional information about an image beyond a single caption. In this work, we aim to understand which image exploration modalities could best support BVI people in identifying errors in auto-generated image captions. To achieve this, we compared three image exploration systems: Facebook's automatic alt text, Microsoft's Seeing AI, and our ImageExplorer. In the next few slides, we showcase how each of the three systems work in greater detail. First is Facebook's automatic alt text feature, which provides details about an image as a list of text that users can swipe through. Information is divided into several categories, including position information, size information, and elements by category.
Position information, heading, on the left, one person, in the center, one person. Size information, heading, minor elements, two people.
Second is Microsoft's Seeing AI, which provides a touch interface, enabling users to explore by dragging their fingers across the screen.
Two items detected. Move your finger over the screen to explore.
Seeing AI will play a melody if their fingers do not intersect with any elements of interest. When they intersect, Seeing AI will play a ding and vocalize a description of the intersected element.
Cat. Cat. Dining table. Cat. Dining table. Cat.
Third is ImageExplorer, our design probe that provides a multi-layered touch-based interface. ImageExplorer begins by vocalizing the auto-generated caption and the number of elements in the image.
Please view in portrait, a black box on a table. There are 4 main objects available. Touch to explore.
Users can touch to explore. When users' fingers intersect with an element, ImageExplorer will first vocalize a description of the intersected element, similar to Seeing AI. If the element contains additional information in the next layer, ImageExplorer will say double tap to explore.
Dining table, double tap to explore. Book, double tap to explore.
When this user double taps on Book, a first layer element, ImageExplorer reveals its second layer elements such as text and drawings.
Viewing book 12 sub-objects available. Touch to explore. Double tap anywhere to exit. Milk and Honey Rupee Carco New York Times bestseller. The logo on the shirt. Milk, rupee. Honey, honey. Milk. And the shirt is white. Milk and Honey Rupee Carco New York Times bestseller.
Once users are done exploring an element in more detail, they can double tap anywhere on the screen to return to the first layer. ImageExplorer will vocalize the number of elements that have yet to be explored.
Going back to the whole image, 3 objects remaining.
To implement ImageExplorer, we use the mask-RCNN model for the first layer because it can generate polygonal boundaries. We also used Google Cloud Vision's object, face, and text detection and labeling models, as well as the DenseCap model to generate a detail-rich second layer. Participants were asked to use the 3 systems to explore 9 images of 3 different caption qualities. Caption quality was decided based on detailness and correctness of the caption. Caption quality A refers to captions that are mostly accurate, B refers to captions that are partially inaccurate, and C refers to captions that are inaccurate. From our study, we observed that participants were initially unsuccessful in determining which captions were accurate and which were not prior to exploring the corresponding images. Overall, image exploration systems were successful in encouraging skepticism towards imperfect captions. This is shown by how participants' scores for images with lower quality captions decreased, while scores for images with higher quality captions did not significantly change. For image quality A, although participants' average rating decreased, this change was not significant. Additionally, even with a slight decrease in average rating post-explorations, it still remained in the slightly accurate range. For captions of image qualities B and C, the average ratings decreased significantly, which suggests that participants were able to correctly judge that those captions were inaccurate post-explorations. After exploring an image, participants relied heavily on information they gathered when judging caption accuracy. For example, for image 3B, a cat sitting on a chair, some participants were able to figure out that the cat is on top of a dining table and next to two chairs when exploring using the two touch-based systems. They decreased their scores because touch empowered them to understand the spatial relationship between the cat, the chairs, and the dining table. Although all image exploration modalities were successful in encouraging skepticism towards imperfect captions, ImageExplorer elicited the most correct explanations across all caption qualities due to greater amount of detail. When comparing a text-based system to a touch-based system, there is tension between mental effort and image understanding. Text-based systems are quicker and simpler to interact with as they allow users to explore the information in a linear manner using a simple swipe gesture. However, touch-based systems are more helpful for image understanding because they are capable of providing more information such as spatial relationships. Additionally, layers are helpful because they not only present information in an organized, hierarchical manner, but also give users the autonomy to choose whether to view the additional information. This tension is reflected in the overall ranking, where approximately half of the participants preferred Facebook, a text-based system, and others preferred ImageExplorer, a touch and layer-based system. Based on these results, we believe that the next iteration of ImageExplorer should include two parts, a text overview and touch details. Such a system will enable users to quickly read through high-level information just as they were able to when using Facebook's automatic alt text feature. Then, if they are interested in understanding an image further, they could choose to receive more details about it through a touch interface and layers, as they did with ImageExplorer. In conclusion, image explorations encourage skepticism towards imperfect AI-generated captions. While a text-based system is easier and quicker to use, touch and layers increase image understanding, and the additional information helps enable BVI users to assess errors in captions. When choosing an image exploration modality, users should decide whether to sacrifice mental effort or image understanding. Thank you for listening to this presentation.